Okay, guys, today we're going to talk about a geometric sequence, and we're going to start by looking at the difference between an arithmetic sequence and a geometric sequence, or maybe it could be neither. So what you want to be looking for is how the pattern is changing. And so we're going to start here and see what's happening in this pattern. So if you notice, I go from 5 to 10 and 10 to 15 and 15 to 20, and that means that we're adding 5 each time. And so I could determine the next number in the pattern by adding 5. And so the next one in the pattern would be 25. That's an arithmetic sequence because we're adding or subtracting the same amount every time. And when you make an equation for it, it's actually a linear relationship. Okay, we have a constant rate of change or a slope. Now, the next one that we're going to look at, let's see what's happening here. Now, I know that 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 343. That is a geometric sequence because we're multiplying by the same amount every time. And if I wanted to find the next number in the pattern, I would just multiply by 3. That would be geometric because we're multiplying by the same thing. And it could be a fraction. It might be a decay. So you might have numbers going down as long as it's being multiplied. Maybe it's being multiplied by 2/3 or 1/4. So that would be a geometric sequence. If you look at the one on the bottom, there's no particular pattern. This is going up by 4. This is going up by 2. This is going back up by 4. Maybe you could say, well, it's going to go up by 2 for the next time. So maybe the next one, it would be 16. Okay. So maybe there is some pattern happening there. It's not arithmetic and it's not geometric because we're not adding or subtracting by the same amount every time, and we're not multiplying or dividing by the same amount every time. Now, I'm going to get rid of the other ones. We're just going to look at the geometric sequence just because we want to be able to write an equation for it. So if we're writing an equation for this geometric sequence, the two things that I need are the y-intercept, or I'm going to call it my zero term in the sequence. So this is the first term, the second term, the third term, the fourth term, and so on. So I need the zero term to make the equation. So I would go the opposite. Instead of multiplying by 3, what we're doing here, we're multiplying by 3. Instead of multiplying by 3 to go backwards, I would divide by 3. So over here, this number would be 3. So that is what I'm going to call my y-intercept. So when I write my equation, so it looks like this, and then the rate to the x power, I'm going to plug in 3 for the y-intercept. So it looks like this. And then over here, kind of a bad example because we're using the same numbers, but over here, I want what I'm multiplying by. Okay, and in this case, it's 3. I'm going to put the 3 here, and that goes to the x power. And that's how I would write that equation. Okay, if I wanted to write it in sequence form, I could write it like this. All right, that's a geometric sequence. Now, let me show you another one. Whoops, sorry about that. It's very finicky sometimes over here. All right, so let's do one that has decay. So it's going down. So let's start with, yikes, 16, 8, 4, 2, dot, dot, dot. And you can see that I'm dividing by 2 every time, or what I would rather you say is multiplying by a half. All right, so that is a geometric sequence because you can see that in each time I'm multiplying it by the same thing every time. And I could find the next number of the pattern by multiplying by a half, and 2 times a half, the next number in the pattern would be 1 because 2 times 1/2 is 1. Okay, so that's a geometric sequence. And if I wanted to write the equation, I'm going to say y equals, let me just change that color. We have y equals, this is the first term, remember? Second term, third term. I want the 0 term, so I'm going to go back one term. And instead of dividing, I'm sorry, instead of multiplying by a half, I'll divide by a half, which is like multiplying by 2. So this one would be 32. And so I would put that here. And then in parentheses goes the number that I'm repeatedly multiplying by. And in this case, I'm repeatedly multiplying by a half. So I'm going to put that in here. That's my growth rate. And I'm raising it to the x power. And if I wanted to put it in sequence form, it looks like this. Exponential function, it's going down. It's starting at 32 at the y-intercept and going down. Okay, and that is a geometric sequence.